Okay everybody, in this lesson about the equations of tangents, we're going to have a talk about how a tangent's equation is related to the graph of the curve. I'm going to use Desmos to show these relationships. We'll talk about the general rule for a straight line and how that leads us to find the equation of a tangent. Through the course of this lesson, we're going to look at two examples. We're going to find the equation of a tangent given an x value, and we're going to find the equation of a tangent given the gradient. We'll have a bit of a discussion about what a normal is, although I won't do a specific example for a normal, and at some stage in this lesson we'll have a quick look at the CAS calculator and how that is used to find the equation of a tangent. So we're going to look at this demonstration on Desmos. You'll see a couple of things. I've got a curve f of x, that's the red curve, a cubic, and I'm showing you a blue line which is our tangent, intersects the curve at one point. The other display is the green point where its y value is the gradient of that blue line. So here's the live demonstration. I'm going to include a link to this page in the description on YouTube. So if you watch this video on YouTube, you'll be able to find a link to this graph. Basically, you can grab the point, the blue point, and as we move through the curve, the tangent is always shown. So that straight line that intersects the curve at one point. And what we can see is that the gradient of that blue tangent is changing, and we're mapping that as we go from left to right and vice versa. So for example, we can see here for this section of the graph, the gradient is always positive. At this point on the graph, it's very steep. It's positive. It does reach a point here, the stationary point of the curve, where the gradient is 0. And there is another stationary point over here, and in between those two stationary points, by looking at the green point, we can see that the gradient is always negative below the x-axis, and then it's positive again. So as I go from left to right, maybe a bit more slowly, just keep your eye on the path of the green dot. So from left to right, and this path is showing us what is happening to the gradient of the tangent as we move from left to right across the curve. So it makes that sort of U shape. I'm going to click on the derivative of f of x, the derivative of the red curve, and we can see that in fact the gradient is actually following a parabola, which is the derivative of the cubic equation, the cubic graph. So two key things to take away from that if we're going to find the equation of a tangent. The first one is that the gradient of the tangent is equal to the derivative of the curve at its intersection. So the derivative of the curve is always changing, but at this point, f prime of a, if this is our x value at that point, will give us the gradient of this tangent. They share the same gradient. And the second point that we're going to take away is that by definition of a tangent, the curve and the function f of x, the tangent and the function f of x are going to share that common point. X equals a, the y value will be the function of a because it's on the function of x. In relation to what we know about straight lines and how we find their equations, we will refer to this point also as x1, y1. So this just is the definition for a tangent and how we find its equation. This is a loose definition, not a hard definition. Tangent is a straight line that intersects a curve at a single point, usually without passing through the curve to the other side. The key point here is that the gradient of the tangent is equal to the value of the derivative on the curve at that point of intersection. So the equation for any straight line, if we know a point x1, y1 and a gradient m, is given by this general form of a straight line. So for a tangent at x equals a on a function that we call f of x, we can see that that formula for a straight line is given by this equation here, where x1 takes the place of a, or vice versa. F prime, this is where our derivative comes into it. F prime of a is our tangent's gradient, and our function of a is our value for y1. So one of the things I guess examiners like about equations of tangents is that they require students to understand both the function and its derivative and use them in the same problem. So we're going to look at a couple of specific examples. Let's look at this one. We've got a function and we're going to find its equation of the tangent at x equals 4. If you can, it's always a good idea to start with a bit of a sketch or some sort of graph so that you know what type of equation you're looking for. When we get that equation, we can see if it's what we expected. So I've labelled the point here where x equals 4 and its y value will be f of 4. This is the curve of f of x. This is our tangent. We're going to find its equation. So I'm going to start by finding f4. That's our y1. That's just a case of substituting 4 into the function. We arrive at a value of 4. So we can see here on the graph too that when x equals 4, y is also equal to 4. The next step is I've found the gradient of that tangent, that green line. I've found the derivative, f prime of x, and I have substituted x equals 4 into that derivative, evaluated that expression, and found out that the gradient of the tangent is equal to 2. And our sketch helps confirm that. We can see that the gradient is positive and steep. And so we are using the general form here of a straight line, and we're finding its equation, substituting f4, the gradient of the tangent, and x equals 4, and expanding and simplifying this equation, we find out that it's 2x minus 4, y equals 2x minus 4, and that was also confirmed because we can see in our sketch we've got a positive slope and we've got a negative y-intercept, which is exactly what this tangent indicates. If I was going to do this on a CAS calculator, I think there's probably a couple of ways of doing it, but I'm just going to go over this one here. In the menu, we're going to use the calculus sub-menu, and you'll find, depending on the version of software on your calculator, we're looking for the tangent line. So in this particular question, I would define f of x. There's our function f of x. We would use this function tangent line, and it requires 3 inputs. It needs the name of the function that the tangent is intersecting, the independent variable of that function, which if you define f of x, it's always going to be x. If it was f of t, you would use comma t. And finally the value of x, where that tangent passes through. And we get our output there, 2x minus 4, the same as when we did it by hand. And just an exam tip here, if you use this function on your calculator, that's fine. Just keep in mind that if an equation is specifically asked for, make sure an equation is given. The calculator doesn't input an actual equation. 2x minus 4 is not an equation, we just call it an expression, but anything with an equal sign, y equals 2x minus 4, is the actual equation of the tangent. We're going to look at a second example. This time we're looking for the equation of the tangent to the curve log x, and this time we're given a gradient of 0.25 rather than a value of x. You can see here, if it's possible, I've started with a sketch. Log x is easy to sketch in the first place. 0.25, so I've sketched a tangent. It has a gradient that looks like it could be 1/4, and I've labelled x1, y1, which from the sketch, the graph, we don't actually know yet. So I'm going to solve x1. In this case, we're going to use the derivative, which we say is 1 on x for log x. Now, when using that particular value x1, 1 over x1 should be the value of our tangent, which we know is 1/4. Solving that equation tells us that x1, the x coordinate of this point, is equal to 4. And so evaluating the y coordinate, we're just going to use the function log x, and so we can use log 4, or you might simplify that to 2 log 2. It probably doesn't matter. And then our equation of the straight line, here we've got our general form, inputting all of the relevant information, we get an equation which is y equals x over 4 minus 1 plus 2 log 2. So this question was different because we were given a gradient rather than an x value. Just a word about normals. Normal is perpendicular to a tangent. So a tangent follows the gradient of the curve. The normal would be perpendicular to that value of the derivative. So you probably recall something about perpendicular gradients being negative reciprocals. So here's some examples. If my tangent has a gradient of 2, my normal would have a gradient of -1/2. Negative 2/3 would correspond to positive 3 over 2. Positive 1/8 would correspond to -8. Point being, if we can use our derivative to find the equation, the gradient of a tangent, we can make a deduction about what the gradient of the normal would be. Here's a diagram that shows both the tangent and the normal at a particular point. We can see that the only difference, they both still share that one point, that the tangent, where the tangent intersects the curve. In our general form for the straight line, if we want the equation of the normal, we're going to use the gradient of the normal rather than the gradient of the tangent, of course. We would still use our derivative, find the equation of the tangent, and then from that deduce the gradient of the normal. So just a quick review. We've talked about how a tangent's equation is related to the graph of the curve, and remember, I'll include a link to the Desmos demonstration. How do we use the general rule for a straight line? We've converted the general formula into a rule that we can use to find the equation of a tangent. We've seen 2 different examples on how to find the equation of a tangent, depending on the information that we've given. We've just had a quick chat about what a normal actually is, how we find its gradient and equation, and we also had a quick look at the CAS calculator, how we can use that to find the equation of a tangent, and what we have to keep in mind if we're responding to questions on exams. So if you could make note of any questions you have, any questions you want to bring to class, and please complete the Google form to log your attendance, complete the questions to check your understanding. Thanks very much.